Very good evening to everybody. I am Ajit Manna. I am here going to solve exercise 2.2 of class 11th maths. Welcome to our channel. Here is the first question. They have given a set A which is defined as 1, 2, 3 natural number up to 14, and we have to find a relation which is defined like this. Okay, and after defining the relation we will have to find the domain, codomain and range for this. Okay, so let me solve. Okay, so they are saying r is equals to x comma y such that 3x minus y is equals to 0, where x and y belongs to a. Okay, so now what we can do here is we can simply we can put x and find out y. So if we find y is equals to 3x, okay, so if we put x is equals to 1, we will get y is equals to 3, so we get 1 comma 3. For x is equals to 2, we get y is equals to 3 to the 6, so we get 2 comma 6. If we get x is equals to 3, we get y is equals to 9, so we get 3 comma 9. If we put x is equals to 4, we find y is equals to 3 4 the 12, the 4 comma 12. If we put x is equals to 5, we get y is equals to 3 5 is 15, which is not present in this set A. Y is not present in A, so this will not include here in the set. So we found the relation set, which is 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. Okay, so what is domain? Domain is the first element of relation. So these are the domain. So we'll write domain. You can simply write the definition of domain as domain is the set of first element from relation. Okay, so we get 1 2 3 and 4. And what is codomain? If a codomain is the whole set B. B means this element, but you will have to write the whole set B. The whole set B is itself A, because here we have relation A to A, so A is also in the second set, B is also A, whole set B. So here the B set is also A, so we will write all the elements of set A, 1 comma 2 comma 3 comma dot 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 up to 14. Codomain. Now we will have to find out the range. The definition of range is the second element, set of second element from relation. So what we have from relation? From relation we have 3, 6, 9 and 12. So this is the range, 3, 6, 9 and 12. So that's how we solve our first question. In the first question, let me just very quickly summarize this question up. We have given a set A which is having 1 2 3 4 up to 14 natural numbers basically, and they have defined a relation in set builder form, and we will have to write the elements of that relation in roster form. Okay, So we simply solve the equation 3x minus y. We simply solve this equation 3x minus y is equals to 0. By putting the value of x, we find the value of y such that x and y both comes from the set A, since they have defined that x and y belongs to set A only. Okay, after finding this, we will have to define the domain, codomain and range for this particular question. So we solve here for the relation part, and after solving this we find the domain, codomain and range. This is the easiest definition I have wrote here. The domain is the set of first element from the relation you have defined, and codomain is the whole set B, and the range is the second set of second element from the relation R. Coming to our second question. Second question is saying us that define a relation R on natural number such that they are again giving us a relation in set builder form, and we will have to convert this relation into roster form. Okay, so what they are saying y is equals to x plus 5, and x is a natural number where x is a natural number less than equals to only less than 4. X is natural number less than 4, and x and y belongs to natural number. So we will just put natural number starts from 1, so we will put x is equals to 1, x is equals to 2, x is equals to 3. X does not equal to 4 because they are saying x should be less than 4. So we will put these three conditions to evaluate the value of y. Okay, so y we will get 1 plus 5 which is 6, y we will get 2 plus 5 which is 7, y we will get 3 plus 5 which is 8. Now we will write the relation in roster form, which is 1 6, because they are saying you will have to write first the element of x and then the second element of y. Okay, so 2 7 x y and 3 8. This is our relation we have defined despite the relationship using roster form. So this is our first answer. And after this, write down the domain and range. So domain, let me define it once again. The set of first element in relation R. So what are the set of first element? Set of first element is 1, 2 and 3. So we will have 1, 2 and 3, and then we have range. Range, the definition of range is the set of second element in relation R. Okay, so what is the set of second element in relation R? Second element we can see easily 6, 7 and 8. Okay, I hope you got it. 6, 7 and 8. This will be our part B answer. Let me summarize this question. The question is define a relation R on set of natural number given by R is equals to x comma y such that y is equals to x plus 5 and x is a natural number less than equals to 4. No, only less than equals to less than 4, and x and y belongs to natural number. And we will have to present this relation in roster form and also write down the elements of the set of domain and range. Okay, so we put the value of x in this equation. X is equals y is equals to x plus 5, we put the value of x in this equation, y is equals to x plus 5, and we find the various values of y which will come when we put x is equals to x is less than 4. So there are only three possibilities: x is equals to 1, x is equals to 2, and x is equals to 3. So we put respectively value of x, y, and x 1, 2, and 3, and find out the value of y 6, 7, and 8. And combining this x and y value together for a particular set, we get the relation 1, 6. Similarly, 2 and 7 will be placed together, so we get 2, 7. Similarly, 3 and 8 we should put together, we get 3, 8. And the first part of the solution is completed. If we are going to solve the second part of the solution, we will have to define a set. We will have to define or write down the elements of domain and range. So domain, first element in R, range second element in R. So that's how we did the next part of the solution also. Coming to our third question in this exercise, they are giving us two sets A and B, and they are saying us define a relation R from A to B such that difference between x and y is odd, x belongs to A and y belongs to B. Okay, let me use the pen here and choose a color of this pen. So they are giving us A element 1, 2, 3, and 5. Another set B here 4, 6, and 8. 4, 6, and 9. And they are saying that x comma y, so the difference in x and y, okay, difference between mod x minus y is an odd number, okay, where x belongs to A and y belongs to B. We just have to write, okay. So first we will differentiate this with this, okay. Okay, so 1 minus 4 is equals to 3 because we will have to take a mod, and next 1 minus 6 is equals to, this is the column of x and this is the column of y, and we are subtracting, where 1 minus 6 is equals to 5 and 1 minus 9 is equals to 8. So this will not be considered next column. X we will take and y we will take here. Then we have 2 minus 4, which is 2. Then 2 minus 6, which is 4, and 2 minus 9, which is 7. Next x and y we will take separately. Okay, 3 minus 4, then 3 minus 6, then 3 minus 9. 3 minus 4 is 1. This is 3 and this is 6. Last column we will have to subtract 5 with 6. Okay, so I think there are a lot of elements present in this column, but the reverse is not possible because we have to write the x on the first side. Okay, so x and y we wrote, so 5 minus 4, 5 minus 6, and 5 minus 9. 5 minus 4, 1, 1, 4. So now I am highlighting the set where we find out the odd result basically. So odd result is this, odd result is this, odd result is this, odd result, odd result, odd result, odd result. So we will write these as our relation set, and the rest will not be included. Okay, so I'm taking the pen and we will write this up with this sky color. Okay, so this relationship 1 comma 3, no 1 comma 4 we got, comma 1 comma 6 we got, comma 2 comma 9 we got, 3 comma 4 we got, 3 comma 6 we got, 5 comma 4 we got, 5 comma 6. So this is our relation in roster form, and this is the simple procedure I followed by taking 1 with all these 3 elements. First I subtracted these 3 elements from 1, then I subtracted the set of the element of second set from these 2, then I subtracted this 3 from these 3, this 3 element from the third element of set A, then I subtracted 3 element of B from the fourth element of set A, and that's how we got our answer. Coming to question number 4, they are giving us a picture and figure 2.7 shows a relationship between set P and Q. Write down the relationship in set builder form and in roster form, and also write the range and domain. Okay, so we're going to solve this question up. I'm taking the violet color right now. Okay, so you can see that 5 is going to 3, means they are subtracting 2. 6 is going to 4, so they are again subtracting 2 from 6, and 7 is going to 5, means again subtracting 2. So we can simply write this in equation. It r is equals to x comma y, such that y is equals to x minus 2, where x belongs to P and y belongs to Q. You can write this up, and in roster form what you can write, this is in set builder form, now we are writing this in roster form. In roster form you will just have to write the elements 5 comma 3, 6 comma 4, 7 comma 5. This is the relation in roster form, and now you can write the domain and range. Okay, so domain, the set of first element is 5, 6 and 7, and range, the set of second element is 3, 5 and 7. Solving question number 5 in this exercise. So we have 1, 2, 3 and 4 set A given in the question, and they are also defining a set R defined as A comma B, such that A comma B belongs to A and B is exactly divisible by A. So this is the line where we will have to put our focus on. The question here is B is exactly divisible by A, means B divisible by A is an integer. Okay, so keeping this in mind we will divide A by A. Okay, and we will again reversing the order we will write. Okay, so 1 divided by 1 divided by 1 will not be divisible by any other element. 1 divided by 2, 1 divided by 3, 1 divided by 4 and 1 divided by 5. So except this all will not be possible. Okay, this not will be possible. Okay, then we will take 2 divided by 1, 2 divided by 2, 2 divided by 3, 2 divided by 4, 2 divided by 5, and 2 divided by 6. Again above two equation will possible, but the lower one will not be possible. Now 3 divided by 1, 3 divided by 2, 3 divided by 3, 3 divided by 4, 3 divided by 5, 3 divided by 6. So these above 3 is possible, but lower will not be possible. 4 divided by 1, 4 divided by 2, 4 divided by 3, 4 divided by 4, and also this is not possible here. 4 divided by 5 and 4 divided by 6. So this is possible, this is possible, this is not possible, and these two are also not possible. Now 5 divided by 1, 5 divided by 2, 5 divided by 3, 5 divided by 4, 5 divided by 5, and 5 divided by 6. Possible, not possible, not possible, not possible, possible, not possible. 6 divided by 1, 6 divided by 2, 6 divided by 3, 6 divided by 4, 6 divided by 5, 6 divided by 6. Possible, 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 not, sorry, possible, not possible, not possible. So by dividing all the elements of B by the, we get 1 set, 2 set, 3 set, 4 set, 5 set, 6, 7, 8, 9, 10, 11, 12, 13, 14 relationship elements whose elements are exactly divisible by the elements of first element. Now I will write this. So we are dividing B by A. So this is A and this is B. So do not confuse with this. And because we have to write A first and B later, so we will write according to that. Okay, so keeping in mind this is the sequence we have written: B, A, B, A. B is this element, A is this element. B is this element, A is this element. B is this element and A is this element. Okay, so 1 comma 1 will, okay, then 1 comma 2, then 2 comma 2, then 1 comma 3, and then 3 comma 3, then 1 comma 4, then 2 comma 4, and then 4 comma 4, then 1 comma 5 and 5 comma 5, then 1 comma 6, 2 comma 6, and 3 comma 6, and 6 comma 6. So this is the whole relation they have defined in roster form. Now we will simply have to write the domain and range. Okay, so the domain, I've already told, domain is the element set of first element. I'm just highlighting the domain and changing the color of this highlighter. Okay, so 1, 2, 3, 4, 5, and 6. So this is the domain because domain is the set of first element. Okay, so 1, 2, you're not allowed to repeat any element in the set. Okay, so that's why 1 is coming 2, 3, 4, 5 times here, 6 times actually. So we will not write the 1 6 times in the domain set. If you write 1 time, it means that how many times it can become in the relation set. Okay, 4, 5, and 6. Now if you try to find out the range of this set, so what is range actually? Range is the combination of set from the second element. Okay, so the second element in the relation 1 2 3 4 5 6, Again you got all the 6 elements in this, so we will write 1 2 3 4 5 6. So we solve this question like this. First part is here. First part we have solved here, and the second and third are the simply domain and range of this element. Now determine the domain and range of a relation R defined as x is x comma y plus 5, x plus 5. Okay, so they are saying R is equals to x comma x plus 5. So what you will do? Come on guys, just tell me. Okay, so you will put the value of x in both of these and calculate. Okay, so if we put x is equals to, we put x is equals to 0 here, and we will calculate x, the value of x plus 5. So x plus 5 is 0 plus 5, which is 5. So 5 is present here, but if we put x is equals to 1, so 1 plus 5, which is 6, which is not present in the x set, not present. X 2 3 4 5, none of the elements is present, I know, but I'm just writing the things to just explain you a little bit more clarity. 7 8 9 10. So none of the element of the second part of the relation is belonging to this. We can write here, because they're not saying that we can actually write all these elements in the set. Okay, so in roster form we have 0 comma 5, 1 comma 6, 2 comma 7, 3 comma 8, 9 comma 10, 3 comma 8, after that 4 comma 9, and 5 comma 10. So this is the relation set. Okay, now we will have to determine the domain and range. Okay, so domain, the set of first first element from the relation R. 0 1 2 3 4 5 6, only 5. Okay, and range is the set of second element from the relation. Second element is 5 6 7 8 and 9 10, and this is our answer of this question. Coming to question number 7 of this exercise. Question 7, they are saying x and x cube, x is prime number less than 10. So we will first write the write the possible values of x which are less than prime number less than 10. What are the prime number less than 10? 1 2 3 5 7 5 7, and 6 is not 7, not 7 हो गया, 8 not 9, not 10, not. Okay, so this is the only possible value of x here, and we will have to write the relation. So we will simply put the 1 and write the 1 cube here. 1 and 1 cube is also 1. Then 2 and 2 cube is 8 is here. Then 3 and 3 cube is 27 is here. Then 4 is 4 cube is 64 here. And 5 cube is 125 here. And 7 and 7 cube is, and let me just very quickly calculate it from the calculator, because 7 cross 7 is 343. Might have known this number, and that's how we just write the relation of this question number 7 in roster form. We simply put x here and then the cube of the same number and the corresponding number. Okay, they're not asking us to write down the domain and range, so we're not wasting our time in this question. Moving to our next question. A is x, y, z and b is 1, 2, and write the number of relation from A to B. Okay, so the number of relation we can find out I remember this formula. The number of relation from A to B is basically formula 2 raised to p comma q, where p is the number of element of set A and q is the number of element of set B. So in this question we have number of element here is 3 and number of element in set B is 2. So 2 raised to 3 multiply 2, which is 2 raised to 6, and this is our answer. They are not asking us to write all the possible values of relation we can make. They are simply saying how many relationship from A to B can be made. Coming to question number 9, might be the last question of this exercise. They are saying let R be the relation on Z. Z is the integer. Integer or race number? Race number is Q. Okay. That is the integer, positive and negative integer, such that A and B, where A and B belongs to Z, and A minus B an integer, and write down the domain and range of the R. Okay, so there are a lot of number possible in this range, and they are also just saying that okay, so let me just solve this question with an example. Okay, so A comma B belongs to integer and if we subtract A minus B, which is also an integer, okay, and A minus B an integer, okay, so there are a lot possible. If I just try to find out, if we put 1 comma 0, so 1 comma 0 is also an integer, 2 comma 3 is also an integer, minus 2 comma minus 5 is also an integer, and a number of possible sets will become. So if we try to write the domain is the set of first element, so first element these are also an integer, so domain is also an integer, and range is the set of second element from this relation R, so the range is also an integer. So in this question, because the boundaries are not set and the subtraction of two integers will also come an integer, so there are a lot of possibilities, basically the infinite number we can got in the range and the domain. So the domain and range is an integer, which is basically the Z part of this. So this is the last question of our exercise, and I hope I tried well explaining this all concepts. Thanks for watching. See you in the next videos, friend. Till then, bye.